Hey guys, so we're checking out grade 12 math paper 2 June 2025. In the diagram below, A, D, Q, C and DPB are straight lines. D is a point on the y-axis, A and B are points on the x-axis. The equation of line BC is y equals 2x minus 24 and the equation of line AC is 7y minus x equals 14. It is given that P is 6 and 1, we got Q is 7 and 3, T is k and negative 1 and TP in terms of length is the square root of 293. So calculate the gradient of PQ. So PQ is over here. So our gradient formula, M equals y2 minus y1 over x2 minus x1. So 2 marks, they're just getting us started. So we got y2 is 3 minus 1, then we got 7 minus 6. Just keep in mind that if you started with Q's values in terms of y, 3 and 1, and then x, 7 and 6, we have to keep it that way. If we started with P and then Q, that's fine, as long as we take them in the same order, the y, 1 and 3, and then the P, 6 and 7. So at this stage, we can just calculate them. We got 2 over 1, therefore the gradient is 2. So then 1.2, it says give a reason why PQ over here is parallel to BC. So it's 2 marks. We just calculated that this guy is 2 in terms of gradient, PQ over here, and they have given us the straight line equation of BC. So we're proving PQ parallel to BC because they both have a gradient of 2. The 2 that we have is here in the straight line equation for BC, and then PQ, we calculated correctly that it is 2 as well. So therefore, M of BC equals the M of PQ, 2 equals 2, therefore PQ is parallel to BC. And we just earned 2 marks there. So the next question, if Q is the midpoint of DC, so Q is over here, calculate the coordinates of C. So we need this guy over here. We need its x and its y coordinate. We don't have them. We have the Q here. We have the x and the y over here, and then we just need D's coordinates. So this is a 4-mark question using midpoint working backwards, but we don't have D just yet, but we can just manipulate this guy in order to calculate D's coordinates. Because if we rearrange this in standard form, we have 7y equals 14 plus x. I'm just going to divide it, so I'm going to go 1 over 7x. So I just moved the x here, and then I divided by 7, plus 14 divided by 7 is 2 over there. And then this guy over here is the y-intercept over here. The x value is 0, but now we know due to this y-intercept that our y value is 2. So we have 0 and 2 here, and then we need x and y. Then we just have to work with our midpoint formula backwards. Okay, so the midpoint formula, we're going to treat x and y separately. So I'm just going to say MP of x over here, x1 plus x2 divided by 2. And then over here we have MPY equals y1 plus y2 divided by 2. So at this stage, our x value for the midpoint is 7 over here. Our 1x value is 0 that we calculated for D, and then the other x value is what we want. So we have 0 plus x over 2, and then we can just solve for this quickly. Times the 2 up, we have 14. 0 plus x is x. So we have 14 here. And now MPY, calculating that, we have 3 as the y value for our midpoint. Y2 is 2 over here, plus the y that we want. And then we divide by 2 times the 2 up there. So we got 6, 2 plus y, and we can take the 2 over, and then y equals 4. So our coordinate pair there is 14 for our x and 4 for our y. Okay, great. So this is a 5-mark question over here saying calculate the size of ACB. 5 marks, ACB. So we want the angle here for C. C had the little hat on over here, which meant that was our angle connecting A, C, and then B over here, which means this angle here is a question mark. When we are in our analytical geometry section, the most common way to get any sort of angle is doing M equals tan theta or beta if we are working with this guy. And the most common way to get an angle that is not on the x-axis, because this formula only works on the x-axis, is to do some sort of interior angles of a triangle. Because what we do have is we have theta over here, which means we can unwrap and get the angle using m equals tan theta. And this gradient over here, we had the gradient already actually, was y equals 1 over 7x plus 2. We had that from our previous calculation, which means we can get the angle here using m equals tan theta, making this tan theta equal this gradient over here. Then what we can also do is get the angle of inclination off of the x-axis to get beta, based off of the fact that we know the m here for the straight line equation as well. So once we have this angle and we have that angle, then we can do exterior angles of a triangle, because this whole of beta will equal theta plus c. And then that guy will equal our beta, and then we can work backwards and get our c value. Cool. So we'll take it step by step now. So what we have for this first theta is 1 over 7 equals tan theta. So then in our calculator, we're going to shift tan 1 over 7, and then we're going to get the angle for that. And we have 8,13 for our theta over here. So then we can do the same thing for beta. So m equals tan beta. And then what we do is we make this guy equal 2. So 2 equals tan beta. And then we can shift tan this guy and see what the value is for beta over here. And we have 63.43. So now beta equals theta plus angle C. So we can just write that down. Beta equals theta plus angle C. The reason is because of exterior angle of a triangle. So 63,43 equals 8,13 plus C. We have these guys, and then our final answer for C is 55,30. So now we have question 1.5. It says calculate the area of quadrilateral BODC. Okay, so we just calculated angle C over here. That was 55,30. So they want the area of quadrilateral BODC. Okay, so this irregular looking shape kind of looks like a kite a little bit, but we aren't entirely sure. So we have a couple of options. This is a 4-mark question. So we have two options here. We can either get the area of this triangle and add it with the area of this triangle. So we can either do that, or we can get the area of this big triangle here, ABC, and then we can subtract DOA from there. So I like that method a little bit more at this stage, especially because of this right angle triangle on our Cartesian plane. So a reminder that our values here for D was 0 and 2, and our equation for this guy was 1 over 7x plus 2. So we have the equation of this line, we have this angle, a reminder that this value here was 14 and 4. This is all information we had previously calculated, which we can use as we progress. So that means calculating the area of quadrilateral BODC. What we are trying to do here is to get the area of ABC and then subtract the area of AOD from it. So what we first have to get is the coordinate of A and the coordinate of B, because we don't have that. So we'll want this side. So in order to get the coordinate of A, we're going to have to let y equal 0 for this guy. So if we let y equal 0, we have 1 over 7x plus 2. We take the 2 over, we have minus 2, 1 over 7x, and then we can times this up, which means we end up with negative 14. And that is the value of x over here, which means this value over here is negative 14 and 0. And then for b, what we can do is the same thing. So this guy over here, we make that equal 0. So 2x minus 24, great. And then what we can do is take the 24 over. We have 24 over there. We have 2x over here divided by 2, and then this x value is 12, which means b is 12 and 0, which means the whole length of AB, considering it's on the same horizontal, is 26 units. So AB over here equals 26 units. This is good for us because remember, we want half base times perpendicular height. Okay, so we have the base over here, but we only have a hypotenuse and we have kind of a slant height. But one thing that was good earlier was that we had this perpendicular height if we connected this triangle over here. This perpendicular height, the maximum height of this point, is 4 units over here, which means we have half times 26 times 4, which is the perpendicular height over here. And then we can calculate it, and then we have 52 units squared for the area of triangle ABC. Okay, but then what we want and what they asked for is BODC. A reminder, BODC is over here. We're just going to subtract the area of AOD from this triangle, which means getting the area of this triangle is quite nice because it's negative 14 all the way to 0. So we already have the base over here, and we have the perpendicular height because the perpendicular height is all the way up to 2. So in triangle AOD, we have half base, a reminder base is 14 units, times 2, because our perpendicular height is OD. OD is 2 units up. And then what we have is 14 units squared, which means what we're left with was this guy we just calculated, and then we calculated this whole thing over here. I'll erase all of that now, which means once we subtract this portion from there, we are left with OBCD, and that is what we want. So then last move is saying 52 units squared minus 14 units squared, and we are left with 38 units squared. And that is our final answer. Cool. So now we're on question 1.6. It says if TP equals the square root of 293 in terms of length, determine the value of K, the value of K over here. So this is only 3 marks, which means it's plugging into one formula. So we have the distance of TP. A reminder that all of these are on the formula sheet. We have our distance, our gradient, our midpoint, and the equation of a straight line. So we have our distance of TP, that is the square root of K minus 6 squared plus minus 1 squared. And then we can just go ahead and solve for it. A reminder that TP was the square root of 293 because we're trying to solve for K here, which means we should and we have to know every single other thing in this equation. So TP was the square root 293. And then the nicest way to approach this line is to square both sides, to unhat it. So we have the square root here. We have K minus 6 squared plus minus 2 squared. And then we were just squaring here and squaring here to drop the square root on both sides. So we have 293 over there, and then we have K minus 6 squared plus minus 2 squared is 4 over here. And then we can take the 4 over, which means we're left with 289 over there. And then what we have to do, we're going to have to expand our K here. So we're going to have K squared minus 6K times 2 is minus 12K. Negative 6 times negative 6 is positive 36 over here. And then we're going to take this 289 over. We have K squared minus 12K. 36 minus 289 is minus 253. And then we can go ahead and we can factorize this. So quite a few moves for 3 marks at this stage, but only one value will be true because this quadratic equation will give us 2 values, and only one of these values will be negative and in this quadrant where we have a negative K. If we have a positive K, that is incorrect, and the value here has to be negative for the K. So instead of just factorizing normally, I'm going to use the quadratic equation, and then we can get our 2 potential values of K. So therefore K equals 23 or K equals negative 11. And a reminder, only the negative value can satisfy this equation. Therefore K cannot equal 23, and this will be our final answer for K. So then 1.7 for 2 marks, it says E, A and B is a point in the second quadrant such that ABCE is a parallelogram. Determine the values of A and B. So EAB is a point in the second quadrant such that ABCE is a parallelogram. Determine the values of A and B. So I haven't drawn this to scale, but a reminder that the main thing to look for parallelograms is whether the midpoints bisect, which means the midpoint this way will equal the midpoint that way, which means D is the midpoint. So we have coordinate A, a reminder that coordinate A was minus 14 and 0, and B was 12 and 0 over here. C was also 14 and 4. So we can do inspection at the stage if we want to, but the easiest way is to use the midpoint, the fact that D is the midpoint. So we can just do our midpoint formula working backwards. D's coordinate was 0 and 2, and then we can just unwrap this going backwards. So 0 is the x midpoint equals 12 plus x of A divided by 2, which means 0 times 2 is 0, and then minus the 12 over, we have minus 12 equals the x of A. And then we can do the same thing for y, and then what we're doing is we're making 2 equal 0 plus y over 2. Because this was our 0 here, this was our midpoint, and then we need the other value over there, which means we have 2 times 2, and this goes up to 4. So therefore, YB is 4, the XA is negative 12. And then we have the values of A and B, and E's coordinate pair is minus 12 and 4. Cool. And then question 1.8, the last question of this section. Determine the equation of the line which is perpendicular to AC and passes through Q. So it is perpendicular perpendicular here and passes through Q at 7 and 3 as the coordinate pair. Okay, when something is perpendicular, the first thing to remember is that m1 times m2 equals -1. By that, I mean the gradient of AC times the gradient of this new line will equal -1. So we already had the gradient of line AC. That was y equals 1 over 7x plus 2. We calculated that in one of the previous questions, which means 1 over 7, a positive gradient, times m2, this gradient that we want, equate to -1, which means we can just divide this 1 over 7 here, which means we have -1 divided by 1 over 7 equals m2 over there, and therefore the gradient of m2 is -7. So it is a steep line, it is negative, decreasing from left to right, and that is our gradient there, which means we're just one move away from getting the equation of the line, because y equals mx plus c over here. So we have the gradient, it is -7. All we need to calculate is a c value, and they've given us the coordinate q, which is the x and the y that we need to plug into this equation in order to get c, which means we have -7 times 7, because that is the x value. So our y value is 3 over here, and then we are calculating c over here. So -7 times 7 is -49, and then 3 is over here plus c, and then we can just take our -49 over, it becomes +49, and 49 plus 3 is 52. And that is the value of c, which means our equation of the line that is perpendicular to AC is y equals -7x plus 52. And that is our final answer here for 1.8, earning us 25 marks for this whole section. Great job. Let me know if there are any questions in the comments below, and then I'll see you in the next video.